Good morning. Today, in the third lecture of the Magnetism and Matter, I am going to cover the following topics: Introduction to Earth's magnetism, Theory of Earth's magnetism, Elements of Earth's magnetic field. Now, introduction to the Earth's magnetism. Now, as you know, that whenever we suspend a bar magnet, it always points towards the north and south direction of the Earth's magnetic field. But have you noticed why it is always so? It is always because it is considered that the electric current circulating from the Earth's core to the space give rise to the Earth's magnetic field. In other words, we can say that the bar magnet always, whenever suspended freely, points in north and south direction. The reason behind is that there is a earth magnet inside the earth. Now this earth magnet is supposed to have saved earth from the solar wind, which might cause the ozone layer of the earth to strip away. The SI unit of the Earth's magnetic field, you already know that it is Tesla. So, the reason for the bar magnet suspended freely is pointing towards the north and south is because there may be some type of a magnet inside the Earth. Now, theory of the Earth's magnetism. There are many theories which explains the cause of the magnetic field inside the earth, but still no theory has a valid proof. So there is no valid reason for the cause of the earth's magnetism or why earth has giant magnetic field. But there are some theories related to the earth's magnetic field which help us to understand that why earth behave as a giant magnet. According to one theory, it is believed that due to the dynamo effect, that is due to the motion of the metallic fluid in the outer core of the earth. As we know that metals are in the molten state inside the core, and because of that metallic fluid is moving, due to that electric current flows inside it, and because of this electric current the earth has its own magnetic field lines. So one reason is because of the dynamo effect. Another theory is the rotation of the earth. Now when the earth rotates around its own axis, a strong electric current, since the outer layer of the earth is organized, so it produces strong electric current, as a result of which when the earth rotates, there is a movement of the charged ion, which in turn produces the electric current. So there are the many theories, out of which these two theories are mostly acceptable by all the people. Either it is the dynamo effect or the rotation of the earth. Now, to explain the earth magnetism, a hypothetical giant magnetic dipole is supposed to be located at the center of the earth. Now, this is the center of the earth, and this is the hypothetical giant magnetic dipole is supposed to be concentrated. Now, it does not coincide with the axis of the earth. The dipole is tilted by 11.3 degree with respect to the earth's axis as shown in the figure. So now this is the hypothetical dipole, the geographic axis. This is the geographic axis shown by the dotted line. This is the magnetic axis. Because of the magnetic dipole, there is a difference of angle 11.3 degree between these two axes. Now magnetic equator, geographic north pole, geographic axis, magnetic south pole, geographic axis, magnetic north pole. These are the few terms. Let us explain one by one. That is the south pole. The magnetic pole of the earth magnetism near the geographic north pole of the earth is called the south pole. North pole, The magnetic north pole of the Earth's magnetism near geographic south pole of the Earth is called North Pole. Now, note one thing, that South Pole near the geographic North Pole and North Pole is near the geographic South Pole, means opposite to each other. Geographic axis, the line joining the north and south pole of the geographic poles of the Earth. Geographical axis. Magnetic axis, the line joining the north and south magnetic poles of the Earth is called the magnetic axis. Now, two terms, the geographic equator. Equator means a circle on the surface of a Earth in a plane perpendicular to the geographic axis is the geographic equator, and in a plane perpendicular to the magnetic axis is the magnetic equator. So basically the equator is the circle on the surface of the Earth. The geographic meridian, the plane perpendicular to the surface of the Earth and passing through the geographic axis is called the geographic meridian. And magnetic plane में, the plane perpendicular to the surface of the Earth and passing through the magnetic axis is called the magnetic meridian. These are the few terms or the definitions related with the Earth magnetism. Now some more terms related with the Earth magnetic fields. The magnetic elements. Now the first term is the magnetic declination. So magnetic declination means the angle between the magnetic meridian at that place and the geographic meridian at that place is called the magnetic declination. That is in this figure, the geographic meridian, and this is the magnetic meridian. What is magnetic meridian? This is the plane perpendicular to the axis, and this is the geographic meridian, the plane perpendicular to the surface of the Earth and passing through the geographic axis. So geographic meridian, the angle between these two is known as the magnetic declination. Now it varies from place to place on the surface of the Earth. Also the angle between the true geographic north and the direction of the north pole of the compass when settled down gives the magnetic declination at that point, and it is represented by theta. So the value of the magnetic declination means the angle between the magnetic meridian and the geographic meridian. Its value changes from place to place. The angle of dip or the magnetic inclination. The angle that the direction of the Earth's magnetic field makes with the horizontal at that place is known as the magnetic inclination or the angle of dip. It also varies from place to place on the surface of the Earth. It is 90 degree at magnetic poles and 0 at magnetic equator. At other places its value varies from 0 to 90 degree. Angle of dip is also known as the angle of inclination. So angle of inclination or angle of dip is the angle between the horizontal magnetic field and the total magnetic field. That is shown in this direction. That is this is the horizontal magnetic field, this is the total magnetic field. So angle between them is angle of dip, and it is denoted by letter del. Now horizontal component of the Earth's magnetic field or BH. It is the component of the total intensity of the Earth's magnetic field at a point taken in horizontal direction. So it varies from place to place on the surface of the Earth. It lies in the magnetic meridian. Now BH is equal to B cos delta. From this figure you can also say that BH is equal to B cos delta. At magnetic poles the value of delta is 90 degrees. So at magnetic pole the horizontal component is 0. While at equator, the horizontal component is the maximum or the total value of the magnetic field at that point. Now, vertical component of the Earth's magnetic field. From the word it is clear that the component of the total intensity of the Earth's magnetic field at that point taken in vertical direction. It also varies from place to place depending upon the angle of declination, that angle of dip, that is del. So magnetic meridian It lies in the magnetic meridian and the vertical component BV is equal to B sine delta. Now if we want to find the relation between the vertical and the horizontal component, so from the above two equations, which equation BH is equal to B cos delta and BV is equal to B sine delta. If we square and multiply and simplify, we will get that B square is equal to BH square plus BV square, or the total magnetic field under root BH square plus BV square. And also if we divide these two equations, we will get BV upon BH is equal to B sin del upon B cos del, and BV upon BH is equal to 10 delta. So these are the earth magnetic elements. These are very important regarding the examination point of view. Thank you and have a nice day.